Hello and welcome to The Explainer. We talk about the cloud all the time, right? For our photos, our files, our shows. But what is it really? It's not some kind of magic, weightless thing floating up in the sky. It has a body. And today, we're going to pull back the curtain on the massive physical reality of the internet.
So let's start with a really simple, fundamental question that we probably don't think about enough. When you upload a file to the cloud, where does it actually go? I mean, it kind of feels like it just vanishes into the ether, doesn't it?
Well, turns out the answer is anything but magical. The cloud actually lives inside these colossal, often windowless buildings called data centers. You should think of them as the real-world factories of our digital age, just humming with machines, and built on a scale that is, honestly, it's kind of hard to wrap your head around.
And when I say massive scale, I am not kidding. Just look at these numbers. We're talking about millions of individual computers or servers all linked together. Google, they're running over 2.3 million servers. Microsoft has over a million. Facebook's got around 180,000. These aren't just big buildings, you guys. They're practically cities made of silicon.
Okay, but running millions of machines 24/7, that creates a monumental challenge. It's a problem that really all comes down to one critical resource: energy. Powering our digital lives takes an absolutely immense amount of electricity. So, just how much are we talking about? Well, get this. In the United States alone, data centers are responsible for a staggering 2% of the nation's entire electricity consumption. 2%. That is a huge slice of the pie, all just to keep the internet running.
Now here's where it gets really interesting. Let's look at where all that power actually goes. You might think it's all for the computers themselves, and yeah, that's about 56%. But a massive 34%, that's over a third, is used just for cooling. That's right. A third of the energy bill is basically for the air conditioning, just to keep these digital factories from literally melting down. So, with energy use that's just eye-watering, the industry obviously had to find a way to measure and improve its own efficiency. I mean, how do you even begin to track your progress when you're dealing with millions of moving parts?
Well, they came up with this really simple but powerful metric: power usage effectiveness, or PUE for short. It's just a ratio. You take the total power going into the entire building and you divide it by the power that actually gets to the IT equipment. In a perfect, ideal world, that number would be 1.0.
And that's the whole point, right? Getting this PUE number as close to 1.0 as possible is the name of the game. So, for example, a PUE of 2.0 means that for every watt used to power a server, another whole watt is used for cooling and other overhead. But a PUE of 1.1? That's incredibly efficient. And this is where you can see how the biggest players are in this fierce competition to be the most efficient. It's like a report card. Look at this. Facebook and Yahoo are reporting a PUE of 1.08. Google and Microsoft are right there with them at 1.12. We are talking about absolutely incredible feats of engineering to get numbers that low. And this isn't just about a few companies at the top. The entire industry has made huge strides. The global average PUE dropped from a fairly inefficient 2.5 back in 2011 down to a much more respectable 1.8 just a year later. That represents a massive saving in both energy and cost.
Okay, so we know they're focused on efficiency. But how are these incredible PUE numbers actually achieved? How do they do it? Let's dive into the nuts and bolts of what really makes up a data center.
First, let's look at the money. Over a data center's lifetime, it's no surprise that the servers themselves make up the biggest slice of the pie at 45%. But look at the other costs: the building, the power, the networking. When you're building at this kind of scale, every single percentage point you see here represents a multi-million-dollar decision.
And this means that even the most fundamental choices, like what kind of server to use, are a critical trade-off. Do you go with high-performance rack servers for pure power? Or do you opt for more energy-efficient blade servers, even though they might be harder to cool? There's just no single right answer.
These strategic decisions go all the way down to how you physically lay out the network cables. The top-of-rack approach is fantastic for high data rates, but the end-of-row strategy can be way easier to manage. Every single choice impacts performance, cost, and, of course, efficiency. But beyond efficiency and cost, there is one priority that trumps absolutely everything else: reliability. The goal is to provide uninterrupted service, which means you have to build in redundancy. We're talking backups for your backups and then backups for those backups. The industry even has a formal system for this, called tier classification.
A basic Tier 1 facility might have over 28 hours of downtime a year. That's more than a full day. But a top-of-the-line, fully fault-tolerant Tier 4 facility, that drops to less than half an hour of downtime per year. That level of reliability requires just staggering levels of redundancy.
So, with the demand for data just continuing to explode, what's next? How do data centers evolve to become even smarter and more resilient?
Well, the industry is shifting toward a couple of key trends. First, there's modular design, using prefabricated containers that can be deployed incredibly quickly. And second, geodispersed models. This means spreading data centers all around the globe to be closer to users, to take advantage of cheaper local electricity, and even to use colder climates for basically free cooling. And all of these innovations are really driving toward the same goals. They let companies build faster, operate with ever higher efficiency, and create a global network that's just more resilient to outages or disasters. It's all about building the cloud in a much more intelligent way. Which brings us to our final thought. The cloud has a very real, very large physical body, and it's only going to get bigger. So as our digital world continues its relentless expansion, the quest to power this massive global machine in a sustainable way, well, that becomes one of the most critical challenges of our time.